Hello everyone, I am Nisha Agarwal, Professor in IFTM University. Today's lecture on network analysis. Network analysis plays an important role in project management. It refers to a number of techniques for the planning and control of complex projects. There are two important methods. First one is critical path method and second is program evaluation and review technique. What is network? Network is a graphical diagram which consisting certain configuration of arrows and nodes, which are also called events, for showing the logical sequence of various activities to be performed to achieve the project objectives. Here if we see, so there are two new terms which are introduced. First one is activity, second is node or event. So activity and effort that is required to complete a part of project, it is represented by a symbol arrow. And event, it represents the beginning or completion of an activity. It is represented by a circle. Since there are two processes to solve any network analysis, first one is critical path method. So in this, we have to determine of the time to complete a project and the important activities on which a manager shall focus attention. And the second one is PERT. Since in the critical path method, the time estimates are assumed to be known with the certainty. In certain projects like research and development, new product introduction, it is difficult to estimate the time of various activities. Hence, PERT is used in such projects with a probabilistic method, using 3 time estimates for an activity rather than a single estimate. And these are called optimistic time, most likely time, and pessimistic time. Optimistic time, it is the shortest time taken to complete the activity, which is represented by the notation TO. The second is most likely time, which is the normal time taken to complete an activity, and the representation of it is TM. The third one is pessimistic time. It is the longest time that an activity would take to complete, and the representation of it is TP. For finding the average time for each activity, we use a formula. TA is equal to TO plus 4 times TM plus TP over 6. And the variance of activity time is calculated by using the formula sigma square equal to TP minus TO over 6 whole square. The probability for the project duration is calculated also in the PERT method. For this, we use Z variable, and this is calculated by using the formula Ts minus Te over sigma square root sigma total or summation sigma square for the project length. So here Ts is called the schedule time, T is the expected time, and sigma summation sigma square is the total project length. After this, we find the probability for T is less than equal to Ts by using the normal table. An example on this is an R&D project has a list of tasks to be performed whose time estimates are given in the table, and the table is there. In this table, activities are given in terms of events. What are the name of activity are mentioned, and the timings for completing these activities are also given in 3 time estimates. First one is optimistic time, second is most likely time, and third one is pessimistic time. Problem is there, draw the project network, then find the critical path and find the probability that the project is completed in 21 days. If the probability is less than 20%, find the probability of completing it in 26 days. So now we start its solution. For this, first of all, we copy the table whatsoever is given in the question, and after that we add 2 columns in this. In the first one, we find out the expected time for each activity, and in the second one, we find the variance for each activity. The formula to calculate the expected time for each activity is TO plus 4 times TM plus TP over 6, and for variance is TP minus TO over 6 whole square. So if we start for the first activity, which is 1 to 2, for this, the value of TO is 4, value of TM is 6, TP is 8. So if we substitute these values in this formula, so the value of TA is become 4 plus 4 into 6 plus 8 over whole over 6. That is, by after calculation, it is 6. In the same way, for the second activity 1, 2, 3, we substitute these values, which are 2 plus 4 into 3 plus 10 whole over upon 6. So the value of TA is become 4. And in the same way, we find other values which are mentioned here. On the same manner, now we find the variance for each activity, and the formula is already written on the upside of the table. For the first activity 1 to 2, the value of TP is 8 and the value of TO is 4. It means 8 minus 4, that is 4 over 6 a whole square, and this is 0.44. In the same way, for the second one, value of TP is 10, the value of TO is 2, so 10 minus 2 is 8 over 6 whole square, and it is 1.77. And in the same way, we find other values which are here in this table. So now we start one by one. What are the requirements of this question? First of all, we construct a network diagram. So for constructing a network diagram, we see in this table, the first event is here 1. So we start with event 1, and it is representing by a small circle. If we see in this table, so there are 3 activities which are started with 1. First one is 1 to 2, next one is 1 to 3, and third one is 1 to 4. So these 3 are called the initial activities. So the next activity is given 2 to 4, then 3 to 4, next is 3 to 5, 4 to 6, then 4 to 7, next is given 5 to 7, and the last one is 6 to 7. So all the activities are representing here. Now on the upside of each activity, we note down the estimated time for these activities, which we have just calculated just now, and these are we write in a bracket on the upside of each activity. So in this way, we say this network diagram is completed. Now in this diagram, we start to calculate the earliest time and the latest time for each activity. And it is again, we start with the very first event, that is from 1. As everyone knows, when we start any project, so starting time we assume 0. On the same way here, for the first event, we assume earliest time for the first event 1 is 0. All these timings we represent in terms of by making a box of there, in which in a first partition we fill the earliest timings, on the second partition we fill the latest timings. So for the first event, that is for 1, the starting earliest time is we fill 0. Now we move in a sequence, means in a order 1 to 2, then 3, then 4, like this. So from 1 to 2 if you move, so the duration of that activity is already mentioned in this network, it is 6. That duration we add in a one value, and which is 0. So 0 plus 6, it becomes 6. When we move on a next event 3, so again there is we start with 1 to 3, and on a 1 its value is 0, and duration for that activity is 4. So 0 plus 4, it becomes 4. Now when we come on 4th event, so if we check, so here more than 2 activities are joining on that. So when the situations appear, if 2 or more than 2 activities are joining on the same event, in this situation we find out all the timings from all the paths. And in earliest timings, when we calculate, we select the maximum in all these. So if we move from 2 to 4, so the time is become 6 plus 2, that is 8. If we move from 1 to 4, so its time is 9. And when we move from 3 to 4, so it becomes 4 plus 7 means 11. So in these 3 timings, the maximum time is 11. So on event 4, earliest time is become 11. In the same way, when we move from event 5, so there is a similar activity 3 to 5, 4 plus 8, it means it becomes 12. When we move on event 6 is 16, or on the same way when we move on a 7, so there are 3 activities which are joining, and in these 3 we select the maximum, and it is 24. When earliest timings are completed, we start to calculate the latest timings for each activity. And the process for this, first of all, we assume the last time or for the last event as similar to the last time of that earliest event, that is 24, similar to this. Now the movement for each activity, it becomes reverse on a backward side. So now the movement is 7 to 6, then 5, 4, 3 like this. And for that we subtract the duration for these activities. So when we move from 7 to 6, so the duration of that is written 8. So 24 minus 8, it becomes 16 on 6. And now when we come on a event 5, so 24 minus 4, it becomes 20. Now again when we move on a 4, so there are two activities which are back. First one is 6 to 4, second one is 7 to 4. So when we find the latest timings in this situation, we select the minimum. So if we move from 6 to 4, then the time becomes 16 minus 4 is 11. And when we back from 7 to 4, so time is 24 minus 10 means 14. Out of these two, minimum is 11. So on a event 4, latest time is 11. Now the next movement in a back is on 3 and it becomes 4. On a 2 is 7. And on the last one, since again there are more than two activities are back, and we select the minimum and it is 0. So in this way we have to find out the earliest timings and latest timings for each activity. Now in this network diagram we select those events on which these two timings are same or equal. So if we see here on a event 1 it is same, on a event 3 are same, then on 4, next 6, the last on 7. These events we join by using the double line and it is called critical path, which is called as 1 to 3, 3 to 4, 4 to 6 and 6 to 7. These are the activities which are used in this critical path. And path is 1 to 3 to 4 to 6 to 7. And the duration of that project is here 24 days. Now if we highlight these critical activities in the table, so these activities are 1 to 3, 3 to 4, 4 to 6 and 6 to 7. And according to this, or corresponding these, the value of variance is 1.77, 0.11, 0.44 and 1.77. When we add these values, these are called the variance of the project length. And for finding the probability that the work is completed in 21 days is calculated by using this formula. Here in the question it's already mentioned the scheduled time is 21 days, and which we calculate, that is called the critical path time, or the project duration which we find out is 24. The variance, we substitute all these values in this and start the calculations. So 21 minus 24 is minus 3, and the addition of these four values is 4.109. We find the square root of this, that is 2.027. If minus 3 is divided by 2.027, so it becomes minus 1.48. So through this we find the probability for that formula is there. Here there is a problem key. What is the value of z when z is minus 1.48? From the help of z table, this value is 0.4306. That is we write here, and in this way we find out the chances. This is 0.0694 in terms of probability, that is 7% approximate. Therefore, the probability of completing the R&D project in 21 days is 7%. As in a question is already mentioned, if the probability is less than their 21 days, then we assume schedule time as 26 days, and for this formula remaining the same. Now the schedule time is replaced by 26 days, so 26 minus 24 whole over divided by the same project variance, which is already just calculated now. The square root value of that is 2.027, and by division this becomes 0.9866. Now we find the probability, that is we using the by the same formula, and the value of z by using the z table on 0.9866 is 0.3365. By substituting this values become 0.8365. So in the terms of percentage, it is 84%. Therefore, the probability of completing the R&D project in 26 days is 84%. So this is a way through which we find the critical path and find the duration or find the probability. So I hope you have cleared all these things by this example. Thank you all.